Thank you very much for joining us. I'm super excited to hear this talk by Jeff, who works at Moog Aircraft Aviation Group, talking about autonomous aircraft and flying drones and what's next for personal and private and commercial air transport. So super excited to hear more from Jeff. Jeff will introduce himself more. Quick thank you to Tracer. So this Tech for Sustainability series is sponsored by Tracer. They are a blockchain platform working with the diamond industry. They work with the majority of the diamond industry, working to foster a culture of innovation and encouraging sustainable business practice and ensuring consumer trust in the diamond industry, and working to demonstrate provenance, traceability and authenticity of natural diamonds and helping local economies where they mine. So they enable people to see proof and authenticity of the diamond from mine all the way to shop. So big thank you to Tracer for sponsoring this series. Anybody can find out more at community.tracer.com. And thank you very much for joining us from the Crypto Carry Club. Jeff.
All right, thank you, Erica. As Erica mentioned, my name is Jeff Ehret. I am a business development manager with Moog Incorporated, specifically in the aircraft group. And I work in innovation, which is, I guess, a fancy way for saying advanced research and development. And what I am here to talk to you today about is autonomous aircraft, which is a pretty nebulous term. But we'll talk a little bit about air taxis, drone deliveries, what's possible right now, what's not, where the market's going. I'll try. It's mainly I'm in the U.S., so I'm sitting here outside of Buffalo, New York, as I talk to you. So most of the regulatory stuff, I'll keep it at a very high level, and it's probably based more so on the US, but it's very similar in the UK and Europe. Really where the differences lie are in developing nations, but we'll try to keep it very high level and hopefully fun, and I welcome any questions. So first a little background on me. I'm a prior military officer in the US Air Force. I spent 15 years working for a British defense contractor named Cobham, which is located in Dorset. So worked on everything from actuation systems for missiles to weapon systems, predominantly in the weapons area, and then moved over to Moog a couple of years ago to work in autonomous aircraft and specifically in innovation. And Moog is a worldwide company. We're roughly around $3 billion US in annual revenue. Pretty much everything that we do revolves around motion control. From the aircraft side, we are a world leader in flight control systems and flight control products. Anything that would go on, we're on every aircraft from the F-35 to the 787 military rotorcraft, virtually any commercial or military aircraft in the market. And we do things that control motion, so move flaps, motors, flight control systems, flight control computers. We have roughly 11,000 people worldwide with 100+ locations, including at least 3 or 5 in the UK. So that is kind of the background on Moog. I try to keep it very high level in terms of motherhood and apple pie, and would rather just jump into the fun stuff. So first, let's talk a little bit about air taxis. I'll use the term eVTOL, which is vertical takeoff and landing, and the E is for electric, as well as autonomous aircraft. And all of these things are kind of intertwined. Not all air taxis are autonomous, not all air taxis are vertical takeoff and landing, but they all form a bit of a mix around this technology. So one thing that's really interesting is that you see a lot in the news. We see it in the US quite a bit, and I think it's kind of worldwide, but there's a term that they throw out called either air taxis or urban air mobility, which is kind of a fancy way of saying, you know, in the US it would be Uber. How do you move people around a city like you do right now using Uber or another car service, but how do you do that using an aircraft to cut down on transit time? Say you're in London and you want to move from place to place, instead of taking the underground or an Uber, you could fly with an aircraft. But one thing that's really important to note is that idea is not really new. So in terms of air taxis, National Air Transport started flying in 1926. New York Airways was flying helicopters in New York City in 1953. And my personal favorite, down on the bottom, there's a flying car from 1947. So the ideas are not new. Some of the technologies that enable this are new and are frankly still developing. But the concepts of flying cars, air taxis, urban air mobility, those are actually very old concepts. So when we talk about an air taxi, and I'm going to reference this picture from Uber, from their Uber Elevate platform, which is their version of the air taxi market. So what it shows down on the bottom is it shows an Uber X transit. This is in Melbourne, I believe. And it shows that it would be a 24-kilometer drive and would take 65 minutes. To do the same mission from point to point with an air taxi would only be, point to point is 18.8 kilometers and only 8.6 minutes. So the goal for all of these air taxis is to try and move people faster. It's all about time savings, and time equates to money for people because it's an opportunity cost. And the idea is, how can you try to make that cost more palatable? So one idea behind this is the use of eVTOL aircraft, which is electronic vertical and takeoff and landing. Meaning most aircraft that you would think of as an airplane have a runway, or you're used to seeing a helicopter. I'll show you some examples on the next slide, but some of these aircraft kind of look like you mixed a helicopter, if a helicopter and a fixed wing aircraft had a baby. So the aircraft can take off vertically, and then they can transition to forward flight, and many of them use wings, some don't. But it's kind of a hybrid looking aircraft to probably what you're used to seeing in the aerospace world. So right now, according to the Vertical Flight Society, there's roughly around 250 different aircraft concepts in development. Some of those, I would say it ranges in everything from very small business startups to the likes of Bell and Embraer, Boeing, other large aviation players. So there's a vast, I'll say, canyon of development at various stages and various amounts of funding. But there is quite a bit out there. It's kind of a new modern age for aircraft development. And one of the things that will make this happen more, but also will make this take longer to occur, is autonomy. So if you have watched what Uber has said and other air taxi or air transport providers, one of the key things is that they'd love to get the pilot out of the cockpit. You save costs, you're not paying a pilot, and you can actually, by removing the pilot, you're able to carry another human, so it makes the economics of the whole mission better and allows them to turn a profit much sooner. But right now, we're used to having, I don't know how many people, and I'm in this space, I work in autonomous aircraft, and I think if I got on an aircraft to fly somewhere, I'd be a little concerned if there was no pilot. Just at the moment, it's kind of a, what you're used to, a culture thing. But as the systems are developed, they actually become better and better. And what I'm showing here is that, right now you have a pilot. In the very, very near future, that might be more of a flight manager, whereas what I mean by that is the pilot may not be doing all of the flying. He might be what we would call fly by mouse. They're managing systems, they're doing other things, but they're not necessarily doing all of the flying, but they're there in case something happens. And that's what we as humans like to know. If something bad occurs, someone's going to help fix it. And that may transition to a remote pilot. So now you'd get in an aircraft and there would be no pilot on board, but there would be a pilot at a remote location who's overseeing the flight and managing it. And then in the future, it would be a true autonomous platform where you do get into an aircraft with your friends and there's no human, there's just a place for you to provide payment and tell it where you want to go, and it would safely get you from point A to point B. One of the biggest things that's really making this difficult, the aircraft technologies are there in various stages to make these kind of things happen. It's really an economics question of how do you make the flight that I show here, how do you make that flight from one part of Melbourne to another how do you make it cost the same as the Uber trip on the ground? Because if it's, if it's $50 on the ground, but it's $250 in the air, maybe not everyone is willing to take that. It becomes an opportunity cost trade-off for your time. So the idea is to get the economics to come down enough where it becomes more acceptable and more available to the general public. So when I mentioned that these aircraft look different than what you're used to, you see there a bunch of different, and I apologize for my dogs in the background. I warned Erica that that would probably be the case. You may hear some barking dogs. So these aircraft do look different and feel different than what you're used to in terms of what you think of as an airplane or a helicopter. Some of these aircraft, you saw probably behind me in my picture on the left is the Surefly aircraft that we've been developing. In the center on top is a German company called Lilium, which is using it. It's an electric jet essentially where the wings tilt forward. They tilt back to take off and then tilt forward. And when you fly, Whisk is on the top right, and looks a little bit more like an airplane, but you can see the propellers, which are pointed up, so that when it takes off, it climbs like a helicopter and then transitions forward. In the center is a Chinese company called Ehang. They're one of the probably folks outside of the US and the UK really far ahead in this in terms of the aircraft, all of the systems that go with it. On the bottom right is actually a UK company called Vertical Aerospace. I was telling Erica, they've done a host of different aircraft and flown them. And that one on the bottom is a new concept vehicle that they're working on, which is a vertical takeoff, all electric aircraft. One of the interesting things here is that as these aircraft start to develop, you're starting to see traditional automobile companies get into this market as they potentially see where regular automobiles might have a lesser role. So Hyundai and Toyota both have invested heavily in this market. And then on the bottom left is a company called Joby, who is developing that aircraft is undergoing flight testing or soon to be flight testing. And they're also working with the US military in addition to air taxi services. So one of the key things is as you look at those, maybe on the top left, the Surefly aircraft looks more like what you would think of as a helicopter. It's definitely not in the way it flies, but the rest of these aircraft are totally different from what you would normally see at an airport or what you're used to seeing flying overhead. So it's pretty interesting. It's a big, I'll say it's in the hype cycle in terms of development, and venture capital money is just getting thrown around left and right to a lot of these startups. But there are definitely challenges to this, and there are reasons why. Eric asked me, well, when will I be able to get an air taxi? The technology is there. It's probably not fully mature yet. You may start to see things like that in the near term, the next couple of years, but true autonomy, we're quite a ways away from that. But there's a quote that the gentleman who runs the Vertical Flight Society here in the US has, which I love, and it says, designing an aircraft is easy if you don't know what you're doing. I mentioned there were 250 aircraft in development. I would probably say a good majority of those are what I would call PowerPoint engineering. They have a fancy picture from a graphic artist, and they have enough to go ask for venture capital to try and get their idea moving forward. So there is that side, and then there are the side of folks who really, come from that background. They understand aircraft, or they can put together a dynamite team of the right folks to go after. It's a challenging business for sure. Regulations and certification. So here in the US, and I assume it's roughly the same in the UK, these are new aircraft. So the FAA here in the US is used to seeing a helicopter or a fixed wing aircraft. They know how to work with those. They've been doing it for decades. They know how to certify something. These aircraft are somewhere in the middle, and some aircraft are more airplane and some aircraft are more helicopter. And how do you go about certifying that aircraft is safe for human transport. And when I say certify, there's a reason why aircraft development, and I 2 lines down, it shows that certifying an air taxi could cost $1 billion by the time you're done. And there's a reason for that. And I think a lot of the folks who come from outside of the aerospace world, you're used to like the Tesla, a new automobile, go off and develop it and do things different. Aerospace is different. We are a little bit more used to the way that it's normally done, and which is, I guess, a plus and a minus. In the safety world, that's definitely a plus. There's a reason why when you get on a 737 and there's an issue with the aircraft when you're in flight, there's a reason why it doesn't normally crash. And when it does, it's a very, very, very rare occurrence. So you need to try and get that level of safety down to those aircraft, and that's where the certification comes in. And one other thing with that is a lot of these aircraft rely on autonomous systems, or AI, if you will. How do you certify AI? That's a big question in the aerospace world. How do you know what the AI is going to do when it decides to make a decision to fly here or there or avoid something? And really, when we talk about autonomy, right now we're probably, we use the word automated versus autonomous. And automated might be, I can tell it to fly from point A to point B and follow these waypoints, but I might make the decision still. Whereas autonomy is the aircraft makes all of its own decisions, and there's still some learning and comfort level that needs to be developed in order for that to happen. On the technology front, there are definitely challenges for the electric aircraft in this space. Battery capacity, charging times, the weight, all of those things are limiting factors for this new market, and why some of the players or the early movers are using things other than just pure electric aircraft. But the real long-term vision for this is that these aircraft would be electric powered. They don't need to have gasoline motors or JP8 kind of aviation motors. As well as another technology challenge is air traffic management. So right now, in any area you have air traffic controllers, they're used to routing aircraft in different airspace systems. What they would not be used to is, say, 2,000 aircraft operating over London at any one time, at an altitude of 1,000 feet. A swarm of aircraft over the city isn't feasible right now with the way that air traffic control is done. So how do you do that in a more automated system? It's a whole new infrastructure problem to bringing these aircraft to the market, because you have to develop a whole new air traffic system as well. On the environmental side, there is some concern over noise. Think about a helicopter flying over your house. Now think about 50 helicopters flying in near location to you. It's pretty noisy. So a lot of the research on these platforms, the reason there's been a lot of investment is to try and bring the noise levels down. And this occurs on the drone side as well. If you've ever heard, been nearby a drone, it sounds like a swarm of bees, and that's a pretty annoying sound. So there is some research into how do you bring the acoustics to a level that's manageable within a city or an urban area. Weather is another problem. So I use this analogy quite a bit. If I'm thinking about being in a very small aircraft that's landing on a rooftop in London or LA or wherever you are, that's a really challenging flight environment in terms of updrafts and turbulence and interactions with the airflow around buildings. And so it is a very difficult flight environment. Usually if you fly on a large airliner and you fly through weather, yeah, it's a bit annoying, but you're only in it for a very short time, and then you might climb out to a different altitude. If you're operating inside the city at low altitude, there are very few places where you can just say, I'll climb 1,000 feet and get out of the weather, because you won't be able to. So aircraft weather is a big challenge for this as well. And then infrastructure. So the air traffic management part is a big infrastructure challenge, but vertiports, which are what we would call the places where you might get on an air taxi in the city. Those don't exist right now. So to go off and invest in developing all of these vertiports would cost a large amount of money, probably more so than what venture capital could afford, and it would need to be government subsidized, or you would go through different routes of saying, hey, we're going to modify this existing parking garage into a place that can operate these aircraft. And it's a series of very small steps, no matter which way you look at all these challenges. Each small step has to move forward, and then you'll start to see bigger change with the way that the aircraft operate. And the last one is safety. So this little chart on the right is a really good example, and it's probably the only technical thing I have in here. But when you measure reliability in an aircraft, you look at something, a best in class right now for a large aircraft would have it's called 10 to the minus 9th. So one failure per 1 billion flight hours. So it's a very, very rare occurrence. And a lot of the aircraft that you fly commercially on, most of the real flight critical systems meet that level of reliability and redundancy. Whereas a best in class helicopter might be 1 to the minus 6, so 1 million flight hours. And the way you can see how that impact is, if you take on the left in the gray, you see 100 aircraft operating 500 flight hours a year. Well, if you use the 10 to the minus 9th, that means you have a critical flight failure every 20,000 years. If you go down to the minus 6, it's every 20 years. If you go down to 10 to the minus 3, it's every 7.5 days. So if you drop down to the very bottom of that and you think about air taxis, so 50,000 aircraft flying 3,000 flight hours a year, which is probably the long-term goal for this. If you have the same safety level as a helicopter, right now you would have a catastrophic accident every 2.5 days somewhere in the world, which is crazy from an aviation safety perspective. So the idea is, how do you take that and make it more like the stuff in the green that is more acceptable? And what you'll see is a lot of folks will say, well, we have a parachute. That's going to save us. If there's a problem, we pop the parachute and our air taxi gently falls down to the surface. That's pretty interesting and neat from a real general perspective, but picture yourself in an air taxi, you're over London, you're at 1,000 feet, and you have to pop the parachute because the motors have failed. One, that's a pretty scary circumstance, but two, now the aircraft is falling under parachute that's completely unguided. So where is that aircraft, that several 1,000-pound aircraft, going to land? Is it going to hit a building, at which point your parachute is probably useless, and then you'll just fall to the ground? Or is it going to land on a car? Is it going to cause damage from below? So from our world, we look at, say, that parachute is a complete, absolute last case. Everything else has failed. You're at that once every 20 years, or once every 6.5 year kind of thing, where everything went bad. Okay, a parachute is your last line of defense, but let's hope we never have to get there. So that's really some of the challenges around what's keeping you from getting on an air taxi tomorrow and flying point to point somewhere around London or wherever you're located. So the air taxi part is the sexy part that everyone loves to go after with venture capital and investments and new developments. What I see actually is a much nearer term thing I like to call dull, dirty, and dangerous missions. These are missions that are not sexy from the venture capital side or the investment side as much, but they are missions that can use these same technologies in a much shorter time frame. So that might be medical transport, it might be cargo transport to remote communities, or within war zones. So any place where there are less people to fly over, less things to hit, and they could also be suited quicker to this type of technology. And where you're seeing a lot of these things being tested on both the large aircraft side and the small drone side, they always start off in remote areas because it's much easier to get a clearance to operate these types of platforms when you're flying in, say, like northern Canada, where you're flying from an airport to a village 200 miles away. There's nothing in between, so there isn't as big of a worry because it's all about risk. And the other part that I mentioned about the developing world is, if you want to fly an unmanned aircraft in the US, the UK, somewhere in Europe, there are regulatory agencies that govern that very strictly. And when you look at some of the developing world, there's a lot of stuff going on in Africa that just, companies go to Africa, or a lot is actually being done in New Zealand as well, because they're a little bit more open to some of the testing, where these people can go and fly aircraft, test aircraft, build up their hours doing these dull, dirty, and dangerous missions, develop the technology, and then it would have a bit stronger pedigree when you start talking about air taxis operating in urban environments. So in each of these sections, I do have just one slide of what Moog is actually working on. So we're a controls company. You see in that slide, as well as my background, the aircraft called SureFly. So that is it's a two-person, we call it an Octocopter. There are 8 propellers. It looks like a helicopter, but it doesn't fly like a helicopter. It can carry 2 people or 500 pounds of cargo, either manned or unmanned. Our goal for that aircraft is an hour flight time under max loading. Right now, it's all electric. The goal for that would be to be hybrid electric, because it gets us longer flight times with the current battery technology. In the future, I imagine it would be fully electric at some point. So the idea behind entities, if say we wanted to offer this to the military, right now, if the military wants to move cargo from point A to point B, they have to have a helicopter with a pilot who's been trained and rated, went to flight school, got their wings, and fly that aircraft, which is very expensive to fly. An aircraft that has simplified vehicle operations, it's much easier for us to have a pilot on board and use it as an more autopilot type of system, where the aircraft will have the ability to take off, hover, transition to forward flight, fly waypoints, do precision landing, all without the aid of the pilot, but the pilot is there in case anything happens. And that will allow us to fly that aircraft and do demonstrations much sooner than if we were trying to convince the FAA that we took this helicopter and made it completely autonomous. And we are actively flying that aircraft pretty much on a weekly basis. So our focus at Moog is not necessarily on, even though SureFly on the left is a new platform, OPV is optional piloted vehicle, fly-by-wire. We're looking at energy storage solutions, because most of these aircraft will be electric propulsion motors, smart actuation. Our background, again, in the beginning was that, we're on all these commercial military aircraft. Well, as these aircraft start to look like the ones I showed you, they don't have traditional control surfaces like flaps and rudders and ailerons. So we're looking at how do we use our background to work our way into that market so that we have growth in the future. So that was air taxis. How are you going to potentially move around the city? One thing I will add to that, if you look at some of the timelines, because I know Eric asked me when would this happen, there are things that say as early as 2023. I think that's probably a bit sporty, maybe in a very, very limited test environment. I think you're looking more towards the end of the decade, where things are more widely rolled out, and it'd be more something that more the average person could use. So drone delivery is the next topic, and I'm involved with both of these, so it's why I chose to kind of do it this way. So drone delivery, you've seen quite a bit in the news. Lately, it seems like there's a pretty large hype cycle around all of this, and the idea behind drone delivery is really that kind of last 10 miles of how do I get something from a store or a shipping source, how do I get it to me at my house quickly and on demand. So there's been, I think Amazon came out and said that they were going to start using drones as early as 2012. They aren't there yet. It's not widely rolled out at all. But the development has really spurred kind of a, just like all of those new aircraft for the air taxi side, there's a host of new aircraft on the last mile drone delivery side. And some of this has been in the news quite a bit. The top left, this was just from last week. Walmart is rolling out a demonstration program for delivery from their stores to the houses. I think it's in Arkansas is where they're looking to test it. On the top in the middle is a company called Manna, and they're over in Ireland, if I recall, where they're doing food delivery with using a drone, and it slides food in the back and flies to your house and then drops food down through the middle from a hoist for you to pick it up. On the top right is Google Wing. And there in that picture, it shows them demonstrating delivery of a FedEx box. They've been flying over in New Zealand for quite a bit. They're also flying here in the US, in North Carolina. On the second row is Matternet, and the one next to them is Wingcopter. Both of them have signed on with UPS. Matternet has been doing drone deliveries in Europe and also in the US, and they're doing a lot of medical transport of blood samples and things like that. Wingcopter has been flying quite a bit in Africa, but is now signed on with US, and that aircraft can go quite fast and a pretty long distance to deliver packages. Bottom right is Amazon's drone. That looks quite a bit different than the rest of them, and that's actually designed to kind of take off. That center section would point straight up. It would take off vertically and then roll forward and fly to fly quite a bit faster. And the same in the bottom center is the Uber's version for what they're trying to develop for Uber Eats. So there's probably as many small drone delivery concepts in play as there are same as the 250 kind of large air taxis. So there are quite a bit of people chasing this, and everything from what I would call mom and pop developers, so very small 1 or 2 person companies, to companies that are very well backed with venture capital, to companies like Uber and Google and Amazon who have their own funds to go after it and chase it. So this is a way for me to get a product delivered to my house via drone, whether it's food or medical or what have you, without having to interact. So that's been a big push here in the last, say, 6 months. And when you think about the environment that these drones are operating in, you get on a commercial airliner, you take off and you land. Usually the two most dangerous parts are the takeoff and landing. Everything in between, you're cruising at altitude, and there's really nothing to hit up there other than the random other aircraft. But now think of a drone flying in a city at 150 feet off the ground. There are power lines, there are buildings, there are trees, there are other things that are there that normal aircraft don't ever have to worry about. And things like a helicopter, the pilot visually says, well, I don't want to fly into that power line, I'll stay away. So how does the drone know that there's a power line there or a building? And that's what we would call detect and avoid. And those technologies are developing, they exist, but it's an extremely challenging flight environment. And now talking about doing it over other people, over people's property, beyond visual line of sight. So that means the pilot can't actually see the aircraft that they're operating. It's just on its mission. How do you do that with the communication system? So I mentioned with the air taxis, you need this whole new way for air traffic management for these air taxi vehicles. Well, you need the same thing, perhaps even more so, and in a bigger scale for thousands of drone flying over a city at any one time. How do you do that? The technologies for all of these are developing, but they're probably not yet there in terms of being ready for prime time in a mass rollout. But there is quite a bit of investment going into it, both private and investments from the companies themselves. to develop these technologies. And it is a pretty exciting time for this capability. And you will see this, I think you'll see this in ramping up more and more over the next year or two. One of the key things as well is regulations, which they do vary by country. The US and I think to an equal extent, probably most of Europe is very strict in terms of allowing aircraft to do exactly what I said. So the aircraft takes off from a store and flies to your house completely autonomously without anyone actually being able to see it. The person who's flying it is only looking at it remotely. That's very risky. So the US is very strict, and they're requiring these small drones to be type certified, just like a large commercial aircraft would need to be. It's not as, I'll say the level of strictness is not the same as a 737, but it is much more so than just putting an aircraft together and say, look, I can do this. Right now, there are no aircraft that are actually certified to do that in the US. There are a handful of aircraft that are very close, that they're in the pipeline with the FAA, but no one yet is actually achieved it. And one of the ways that they mitigate some of the risk is to say, we are going to certify each and every route that aircraft flies. So if you sign up with a food delivery service, they would have to certify the flight that they would fly from the restaurant to your residence. And that's just a different way that you would do it with a large aircraft. So it's a developing thing. There's lots of discussion, and there's lots of hopefully change on the way, but you can't compromise on safety, and that's where the type certification really comes in. It's to ensure that the aircraft is safe. So the developing world, though, Africa and other places are much less strict with this. Frankly, there are just less things to hit because there's a lot of more rural areas and more sparsely populated areas. So it's a great test bed. So I think you'll see a lot of that stuff happen just by necessity. And Zipline has been doing it in Rwanda for a while. They've flown well over 100,000 flights where they deliver blood products and blood tests to remote villages. They've got an amazing system of logistics carrying that out day in, day out. They can do it there. They're starting to look at how to do it in the US, but it's a much different environment to have to work with. One of the things that, I'm part of a $3 billion company, but I work with a ton of startups, and it's one of the parts that I really enjoy about my job. But, we have to be very wary of just the fly-by-night operators that come in to this and say, hey, I'm going to start delivering products with this drone I just made, or I'm going to use an off-the-shelf consumer drone and I'm going to deliver you food. Can you do it? Technically, sure, but it's those of us on the side of the market that are looking to do this the right way through regulations and through qualification and certification. All it takes is one of those aircraft who are operating kind of outside of that structure to have an issue, and God forbid someone were to be injured or killed. It could totally collapse the whole market for everybody with people who are just operating because they don't know any better. So it is a challenge. And I say, you need to have some aerospace experience. You need to come from a world that understands certification and regulations and how to do it the right way. So do I think it's going to happen? Definitely. I definitely think it will happen. There are many opportunities and you'll see it in many demos, even starting now over the next 6 months, the next 2 years. I think it'll be very, very widespread. Do the economics of it make sense? Yes and no. One of the things I always say is you can use a drone to do a lot of things. It doesn't mean it's the right thing. So there has to be a value add to either the consumer or the delivery company. There has to be some kind of value add there to make it worthwhile. Otherwise, it's kind of gimmicky. So what are we doing in drone delivery? We have a joint venture with a company called the Workhorse Group. Workhorse is a company that actually develops electric trucks for the likes of UPS and the US Postal Service. And they also developed the drone you see there, which is called Horsefly. So we have a joint venture, which I am co-manager of that joint venture for Moog. And really what we're trying to do is they've developed an aircraft and the vehicle, and they have some patents around that. And we come from that aerospace background of how do you get things through FAA certification? How do you operate with an aerospace mindset? So the joint venture is really centered on bringing our experience to their platform and supporting them into FAA type certification. And on the bottom, you can see they did you can go on YouTube. They did a demo a few years ago with UPS where they actually operate a drone flying right out the top of a UPS delivery truck. So it's pretty cool technology. The aircraft can fly a 10-pound payload for 10 miles beyond visual line of sight with all the capabilities that I mentioned previously, and everything with that is developing. It would drop a winch package down to you and drop it off at your predetermined delivery spot. So just another entrant into that drone delivery market, but it's really, from my point of view, it's a load of fun because it really is, you're operating in completely new markets. It's almost like the Wild West in terms of how fast people want to try and move and the opportunities that arise from it. So it's a lot of fun to be on this side of it.
Thank you, Jeff. Really appreciate that. We do have a bunch of questions coming in about battery technology. Are you assuming improvements in battery technology to make numbers work? And to go on from that, do you know how fast battery technology changes? How quickly, for example, how do you pronounce the
Octocopter?
Yes, the Octocopter. For example, how quickly the battery technology will change to enable that to be fully electric, for example? So
from right now, yes, so battery technology is changing. It has to change, otherwise this market doesn't really work. So a great example, I'll use the Robinson helicopter that we have. So there was another company in California who took and made a completely electric version of a Robinson helicopter, all battery, and they were able to fly it for a certain distance. They pulled all the gas motor out and put an electric motor in, which is really interesting, really cool. The hard part is the batteries weighed 1,000 pounds in order to enable like a 30-minute flight. So 1,000 pounds of batteries is a killer in the aircraft world.
And how much would one of those aircraft weigh just by itself?
The aircraft that aircraft carries 4 passengers, so it probably carries around a 1,200 pound payload. So they probably just had enough to have a human in there plus the batteries. Mm-hmm. So yeah, batteries are a very limiting factor. I don't know the numbers in terms of how quickly the rates of performance are changing, but there's a ton of investment going on to try and make those batteries last longer, weigh less, charge faster. So hopefully that's somewhat of an answer, but I'm far from a battery specialist. So.
No, cool, all good, thank you. And regarding the eVTOLs that you mentioned, the sort of the vertical aircraft, what do you think are the main technical challenges for the eVTOL aircraft?
Technical challenge, I mean, technology-wise, there have been vertical takeoff and landing aircraft for many years. So the technology, the challenge there, I don't, it's around the propulsion motors, the transition from takeoff into forward flight. How do you do that reliably and safely? How do you make the systems which you don't have flaps or normal control surfaces anymore? You're using differential propulsion with the motors to turn left or right. So there's a lot of research around that. But I mean, really, the technology exists today and people have the ability to do it. It's a money problem. You need a lot of money to go after these things and to be able to do it reliably. So it is definitely an investment problem for sure. I mentioned, certifying an aircraft costs like $1 billion. Probably, I think the most I've seen raised right now for any of those companies is in $500 million to, maybe $750 million. Toyota and Hyundai, I think, invested around $400 million US in their aircraft. So it takes a lot of money that just, a host of these companies just will never have enough to be able to do it.
Mm-hmm. And talking about money, you mentioned, for example, before we started talking, that the Octocopter they hope to bring the price down to $250,000 per one once it gets to mass market production. Has there been any studies done about costs per individual flight or anything like that, about looking at price points for actual journeys?
So if you look at what Uber's talked about, their idea for air taxis is not that you or I or anyone would personally own them. They would be owned by fleet. The fleet would operate them for someone like Uber or another provider. So that's how you tackle. Most people can't afford $250,000 or $500,000 to go off and buy their own vehicle. But the economics, and Uber has said this, that they're trying to get the cost of that trip closer to like an Uber Black, or Uber, eventually maybe Uber X. But so they need to get it down so that the customer isn't seeing a huge difference in cost to adopt it more. That's a long-term goal. The short-term goal is that it will cost more than just a hired car ride. Sure. But if it's your time savings, if you save an hour, perhaps that's worth it from a business perspective.
Sure. No, thank you. And John is asking, has there been any work done on the economics of an air taxi? I know we just spoke about this, but has there been anything about market price per mile, or do you know any limits on how much one could charge for that?
I have not looked into that part of it because we aren't an operator, nor do we plan to be an operator. Uber has put out a ton of white papers on the economics of air taxis. Mm-hmm. So that would be a place to look in terms of how do they get their Elevate platform to get down to a cost to make the economics work, both from cost to operate. They have amazing models. If you've never looked at Uber, it was super enlightening. They're a data company more than they are a ride sharing company. They have massive amounts of data on everything from where the points in the city are that you would need to operate these types of vehicles to the cost economics of it, right down to how many hours do you fly the battery before you need to recycle it to make it, and what does that cost? So they have really great economic models, which are publicly available through their Elevate platform. They've got white papers on everything. If you do a little Google searching, you'll find some really good info.
No, that's really good. Thank you. Samesh is asking a very interesting question. With autonomous air freight and deliveries coming in the future, is there any work being done to develop a strategy against aerial pirate drones? Now, I would love, first of all, if you could tell us what aerial pirate drones are.
So I'm assuming he means something like what we would call counter UAS. So you have drones that you're doing something good with. There are also drones that are not doing good things.
Are they like big birds that eat the little birds out of the sky?
No, I haven't seen anything where that would use the term pirate, but counter UAS is a term that we would use for how, if you have a drone that isn't supposed to be operating in an area, how do you defend against that? Mm-hmm. So, we think of a sporting event, right? You've got a big, what we would call football, American football. There's 80,000 people in a stadium and someone wants to fly a drone over it. That's not legal. How do you keep that from happening? And there are tools and technologies and capabilities that they can offensively take that aircraft down to keep safety for what they need to do. So I haven't heard anything with pirating. So I haven't heard anything about other drones stealing drones out of the sky. It'll be an interesting place to do some research on, I guess.
There's a few questions through about fuel cells. Is a hydrogen fuel cell a good option for UAVs, or what about using fuel cells to extend the aircraft range?
So there is one company that I'm aware of on the air taxi side who is planning to use hydrogen fuel cells. It's a company called Sky, mm-hmm. and they have a vehicle that is similar to what you've seen. It kind of looks a lot like the Surefly Octocopter, but they're planning to use hydrogen because they just didn't feel that battery technology was there, and they thought hydrogen was a much more suitable thing. There is there's obviously some weight and size constraints with that, the energy density of the hydrogen and that kind of stuff, as well as, even with batteries, just the safety perspective of, you've got compressed gas and what do you do with it? So we haven't done a ton of work. I haven't done a lot of work on fuel cells, and there is some work ongoing out there. But on the small drone side, from what I've seen, a lot of the fuel cell things, they enable a long duration of flight, but they weigh too much, so you can't carry anything.
Right.
So it's really about usability.
What about air control at a micro level over cities? Are there any limits about that? If you had little drones or little aircrafts delivering you your takeaway noodles or bringing you your next Amazon delivery?
So, and I alluded to that in the presentation about air traffic management. Right now, there isn't any system that will, that will control that.
So does that mean you could send these things, or does it mean you can't send anything until there is such a system in place?
You can do it. It wouldn't be legal.
Right.
So you can do, and most of what you see, the slide that I showed with the companies doing demos, all of these demos are really great from a marketing perspective, but they're very, very small and structured in terms of what a real rollout would be. So they're operating in a very strict area under super strict circumstances. Just
in rural areas at the moment.
And some of them are, Matternet flies with, around hospitals. They do blood transfers on hospital campuses. So it's not like mass rolled out to anywhere and everywhere. It's operating under really strict policy in certain areas.
Mm-hmm. No, thank you. One question, is DARPA a good place to test and build up the technology?
Sure. DARPA in the US is the Defense Advanced Research Projects Agency.
Mm-hmm.
So DARPA, sure, they do completely secretive developments and stuff for advanced R&D. On the drone delivery side, it probably isn't super applicable because everything it's probably too small. I would hazard a guess that DARPA is definitely doing work in terms of autonomous systems, unmanned systems for military applications, cargo delivery, you name it. I think that's a pretty safe bet. Mm-hmm. But a lot of those things, if I develop something from DARPA and it's an air taxi, or I develop anything from the military perspective and it's an unmanned platform, I can't just go sell it to anywhere else in the world because it's now controlled under strict export regulations. So you really have to be careful how and where you develop things, depending on where you want to use them.
Mm-hmm. Okay, thank you. David is asking, and saying first of all, thank you, but that the VTOLs, the vertical transports, can be a solution to avoid the main challenges in taking off and landing. But what do we need, technologically speaking, to combine VTOLs with full electric air cabs and air cars and other aircraft in the future?
So personally, I hate the term flying car. Everybody uses it. There will probably never be what I would call a flying car. You're going to have some kind of flying vehicle, whether it's purely in a taxi perspective. So what are the challenges there? I mean, the technology exists today. It is around batteries. It is around air traffic management. I don't think they'll necessarily integrate with ground vehicles. There are some concepts I've seen where you're on you're in a pod and you get shuttled to an airport, and then the aircraft kind of grabs your pod with you inside it and flies you somewhere. Mm-hmm. There are ideas around that. Those are probably not in the majority of where the development lies. Because it's just that's neat from an artist perspective or a concept idea perspective, but now you've got to certify not only an air vehicle, but a ground vehicle too, mm-hmm. and how they interact together. So that is a pretty big challenge. I don't know if I quite answered his question, but.
Cool, thank you. As a UAM grows, do you believe the current infrastructure can sustain all the estimates? And due to safety concerns alone, what do you believe the FAA or CAA will realistically ever improve about pilotless aircraft? And
so right now the answer would be no. The system can't support. If you take the numbers that they were talking about, there isn't a system in place yet to do it. Mm-hmm. So there will be billions of dollars of infrastructure that need to get put in place. either from a private or federal level. I think that the FAA, the CAA, I think they'll support the idea of autonomous aircraft, but they're going to, they make a point of saying we never compromise on safety. So the technology will probably be there before they're ready to sign off on adopting it. And there's going to be quite a challenge and hurdles and new regulations around how do we certify an autonomous aircraft. We do it, it happens in the defense world, but the defense world is totally different. People aren't, you're not flying overpopulated areas. Typically you're in war zones, so there's less risk. It's all about risk mitigation.
What role do you consider drones playing in the future of aviation?
So I'm a geek at heart. So, and an aircraft one as well. So I envision both the air taxi side, air taxis, the autonomous cargo. I think autonomous cargo is an awesome idea. If you think about how do you get things faster in the infrastructure of how a product you order on Amazon, how it gets to your house, if you can do that faster, cheaper, more cleaner for the environment. So that's where all these things come in. It allows you to do things slightly different and more efficient than you would right now with large commercial aircraft. And the same with the drones. So I think that they get right now it's all about drone delivery. But I think you'll see drones, I like to make the thought that drones are going to do things right now that we can't even imagine in the future. We view them as what we see on the page here, little, kind of toy looking aircraft bringing us our cup of noodles or, a package. But I think that they'll be more ubiquitous than that, and they'll be more tied in terms of public safety and data gathering. When you look at the Internet of Things, now all of these things is a flying data gatherer or network capabilities across cities. So I think those things will all occur, and most of that we probably just can't even understand right now because it just hasn't been thought of.
No, amazing. Jeff, thank you. Really appreciate your time. That was super, super interesting. I'm going to be geeking out some more on some of the names that you've said, but had some really great feedback from that. So really, really kind and interesting. So thank you so much for joining us. And also just lastly, a quick thank you again to Tracer, the blockchain for the diamond industry, for sponsoring this webinar series about tech for sustainability. So thank you to Tracer. That's community.tracer.com. Huge thanks to Jeff. And you've got lots of comments through saying that this was very interesting from various attendees.